Good morning, or good evening, sorry. We are talking today about differential equations. So a differential equation is simply an equation that contains a differential. Now, what is a differential? A differential is simply the dx or the dy. So, for example, a dx, a dy, a dt, etc. So, a differential equation has, just like an antiderivative, an infinite number of solutions represented by what's called, and I believe we discussed this with antiderivatives as well, the general solution. What does that mean? That means that we are going to have a plus c or plus some constant at the end of our function. And again, that's just like with our antiderivatives. We've already experienced this. Now, occasionally we will be given an initial condition. And when that happens, we can then find our value for c. And when we do find that value of c, that gives us the unique particular solution. So how do we go about doing this? In order to solve a differential equation, we must do this first thing here. Without doing this first thing, you can't get any sort of credit or points or anything like that. So we have to have a separation of variables. Separation of variables means we rewrite the equation so that each variable occurs on only one side of the equation. And basically, most of the time, we're going to do that by cross multiplying, but not all of the time. So here's our strategy in our box for solving a separable differential equation. Is first we separate, and once we separate, we're going to treat it like an antiderivative, which means we integrate. So again, those are the two steps: separate and integrate. So let's look at this first example. Find the general solution to the differential equation dy dx equals 2x plus 1. Now, the general solution, that tells me immediately I'm going to have a plus c at the end. So let's go ahead and work out how to do this. And the first thing that I want to do is separate. So let's start with what we have, which is dy dx is equal to 2x plus 1. And again, the first kind of thing we look for is just your basic cross multiplying. And so if I cross multiply, what I have is I have dy times 1 is equal to 2x plus 1 times dx. So we've done step 1. Now we need to do step 2. So our step 2 is that we integrate. So all that means is I'm going to integrate both sides of the equation. And this is what I'm working with, so this one shouldn't be too bad. Don't let that integral of dy intimidate you. The antiderivative of dy is just y. Now, technically, I'm going to talk about this for just a second. Technically, whenever I take an antiderivative, I have some constant that could possibly be there. So for this one, I'm going to say I'm going to call that C1. Now that's going to be equal to, and I take the antiderivative of the right-hand side, of 2x squared over 2 plus x. And then technically I could have some other constant over here. Now, we're lazy mathematicians, so I have a plus C1 over here and a plus C2 over here, and basically I'm trying to get y by itself, right? I'm trying to solve for y. And I would subtract this C1 over to the other side, and I would have C2 minus C1, which simply means another constant. Now, I don't care about the specific value of this constant, and I don't care about the specific value of that constant. I only care about the constant that I'm going to end up with finally over here. So basically all we're going to do with these is in the future we are not going to have a C1 and a C2 when we have the antiderivative of each side. What we would do is we would have a y only on this side, and then on the other side, I'm going to simplify as I rewrite. I'm going to have x squared plus x plus some constant. And again, I don't care what C1 was. I don't care what C2 was. I only care what that final C is when I get y by itself. So in the future, we are not going to be writing the C1 over here. We're simply going to be writing C on the side that's more complicated. Basically, if I'm solving for y, I want the plus C on the opposite side. So my task in this problem was to find the general solution, and here is my general solution. So if I were to take the derivative of this general solution, I should get that right there. And that's all a differential equation is. So technically it's not really new except for the fact that we have to separate our variables before we integrate. So let's move on to the next example, which is nice and easy, because all we're doing here is we have the same differential equation that we had above. Okay, so this is the same differential equation in the first example, but instead of finding a general solution, I'm now finding a particular solution, which means I now have to find C. So let's start with what we found. We've separated, we've integrated, and we have y equals x squared plus x plus c. So now I need to plug in this information. Now, I always identify everything I have before I plug in. Too many people make mistakes when they do this, and I don't want you to do that. This 2 right here, is that an x value or is that a y value? I'm going to label that. That is an x value. This 9 right here, is it an x value or is it a y value? And that one is a y value, and I'm going to label it right here. And when I come over to my function, I'm going to replace everything that I've labeled. Instead of y, I'm going to plug in 9. Instead of x, I'm going to plug in 2. And from here, I'm simply going to evaluate what c is, and that gives me that 9 is equal to 4 plus 2 plus c, which I believe gives me that c is 3. So now I can write my solution, and my particular solution is now y equals x squared plus x, and I replace that c with the c I found, which was 3. So this is my particular solution at the point 2, 9. So if you have any questions, go ahead and write them down so you can bring them into class next time. Going on to the next set of examples. Now we have this differential equation that freaks everybody out because there aren't any numbers in here, and there's x's and there are r's, but we're doing the exact same thing. So we're finding the general solution, which means I'm going to have a plus c. So step 1, separate. So let's go ahead and do that. I start with my dr dx is equal to x over r. And again, I look to see if I can cross multiply and see if that will be helpful, and that will be. So I'm going to go ahead and cross multiply, and I get r times dr is equal to x times dx. I have separated my variables. All my r's are on the left, all my x's are on the right. Step 2 is integrate. So all I'm going to do now is integrate both sides. So let's take our antiderivative now. In this one, when I take the antiderivative of r, I'm going to get r squared over 2. And again, I have a plus c, but I don't want to write it over there. When I take the antiderivative of x, I get x squared over 2. And that's where I'm going to write that I have my constant. I usually write it as C1 just because maybe I'm going to have another constant later. So let's go ahead and work this out. Technically, I want a general solution for r. You can see that I want r by itself. So the first thing I probably want to do is get rid of that divide by 2. So the easiest thing to do would be to multiply everything by 2. And when I do that, I'm going to get r squared is equal to x squared. And then technically this c1 right here, I'm multiplying it by 2. I don't really care what any of those are, so I'm just going to call that it's some other constant. I did something to it. I multiplied it by 2, but I don't care what the c1 is. I just care what my final constant is. So here we have r squared. I'm so close to having my general solution, but I want to get r all the way by itself. So in order to do that, I would need to take the square root of both sides. Now, when I take the square root of both sides, I have this, but what is so vitally important is when I take the square root of both sides, I can have a positive answer or I can have a negative answer. So here is my general solution to this differential equation. And again, that means I have a plus c. Again, any questions? Write those down to bring in for your teacher. Now we have part B. Let me scroll down a little bit, see what we're doing. Now we have a particular solution. Particular solution, which means we're going to find C. And now we have been given some information. So let me write down our function here so that I can have a little bit more room. So r is equal to a positive or a negative square root of x squared plus some constant. And I could just call that c at this point. I don't have to call it c2. I'm going to scroll down now so I can just see the problem. Okay, now we have given r of 1 is equal to 2. So this 1, is that x or is that r? That is x. And this 2, is that x or is that r? And that is r. So I'm going to plug this information in. So I plug my 2 in for r, and that is equal to the positive or the negative square root of, what is my x? My x is a 1. So to work this out, now I have 2 is plus or minus square root of 1 plus c2. So to solve for c2, I need to square both sides. And when I square both sides, I get this. And that tells me that c2 is 3. Okay, so now I can go and I can write my equation. So I know what my c2 is. So r is the plus or minus square root of x squared plus 3. And I go, yay, I pat myself on the back, I did a great job. But wait a minute. I have this plus or minus here because technically in my general solution, this could be a positive thing or a negative thing. I need to be very careful. And now I need to look over here at this r right here. Is this r positive or is this r negative? And that tells me what the sign has to be. That r right there is a positive thing, so my particular solution is the square root of x squared plus 3. Okay, we must identify whether it's the positive or the negative. Again, any questions, bring into your teacher. So let's look at part C. Part C, we're doing a particular solution again, so that means we're going to find C. And now we have R, the same function that we had. Let me write down our function again. R is plus or minus square root of x squared plus C2. And now it looks like we have new values of R and X. So this 1 is my X, and this -2, that's my R. So we can see the slight difference. This 2 right here is negative. Guess what? That tells me immediately that I will have the negative sign in front of the square root when I have my final answer. So let's plug all this in. My R is -2, and that is going to be equal to the plus or minus square root of something squared plus C2, and my X in this case is a 1. So now I have -2 is equal to plus or minus square root of 1 plus C2. And again, I need to square both sides. And I'm going to move to the right to do that. Actually, do I have room to go down? I do. So I'm going to have, I square both sides, and 4 is equal to 1 plus C2. And look at that. C2 is the same. It's 3. So now my function R is plus or minus square root of x squared plus 3. And again, I need to stop and look. I have a plus or minus right here. However, I just talked about the fact that my R is a negative. So that dictates that this sign here has to be negative square root of x squared plus 3. And there's one thing that you do have to be careful of when you are working with differential equations. And that is all we have for today. So I hope you have a wonderful day. Bring in any questions to your teacher.